Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is integration. What you are going to learn today is definite integral. So let's begin. So after completing the very lesson today, my dear student, you will now be able to find the value of some definite integral. This is what I hope you'll be able to do after completing the very lesson today. My dear student, your favorite segment of the lesson. Today, I'm happy also to give you another interesting property of this number 13. This 13 has a lot of interesting properties, like I keep saying. I'll give you another interesting property of this number 13 after completing my lesson today, so don't go away. To begin the lesson, my dear student, let me explain the concept of definite integral. So suppose you have a general function y equals to f of x. And this is a function such that the integral of the function f of x with respect to x is given by capital letter f of x. So this is the integral. That is the result after integrating this very function f of x. It gives you another function denoted by capital letter f then of x. So if this f of x is the integral of this original function f of x, then the definite integral of the original function of f of x between the limits a and b. B will now be the higher limit while a is now the lower limit. And that definite integral between these two limits will now be given by this simple formula. It says integral from a to b of the original function of x with respect to x is now equals to capital letter f of b, that is the higher limit, minus f of a, that is the lower limit. So what this formula simply tells us is to now find the integral of the original function. In that integral, what you now do, you now substitute the higher limit. The value you now have is now f of b, this capital letter f of b. Then also substitute the lower limit in the integral function. That gives you this value, and when you subtract the value, that is substituting the lower limit in the integral function, replacing x by that lower limit and replacing x by that higher limit. When you now subtract the two values, what you now have is the definite integral of that function between a and b. We are going to take examples how we can now find the definite integral of some function. So let's just move and take examples. Example number 1, we asked you to evaluate integral from minus 2 to 1 of the function 6x squared minus 5 with respect to x. So solution to this very problem. What we now do, we now write down the formula. It says the definite integral from a to b of the function f of x with respect to x is given by f of b minus f of a, where a and b are respectively the lower and the higher limit. So what we now do is to find the integral of this very function and replace this lower and the higher limit in that integral function. What we now have, the value after subtracting will now be the definite integral. So let's just move. So copying the given text, that is integral from minus 2 to 1 of this function 6x squared minus 5 with respect to x. So what I'm going to do first is to find the integral first. So that will now be the integral of 6x squared. It will now be 2x raised to the power of 3. And the integral of minus 5 will now be minus 5x and then plus c. Then I will now copy those limits, that is from minus 2 to 1. Look at my limits there. So what I'm going to do, this is now the integral of the original function. So I'm now going to replace the x first by the higher limit, that is 1. Then later replace the x by the lower limit, which is now minus 2. Then the two results, I'm now going to subtract the 2. So let me just move. So starting with the higher limit, in this case it is 1, my higher limit. So I'm going to replace the x by 1. So I'm going to have something like this: 2 times 1 raised to the power of 3 minus 5 times 1. I have replaced this x cubed by 1 raised to 3 and replaced this x by 1. Then I'm also going to replace the x in this integral function by the lower limit, which is minus 2. This minus is for this minus in this subtraction in the formula. It says f of b minus f of a. So this is my f of b that I'm having right now. Then I will move to get f of a. Minus is this minus. So I'm now replacing anywhere I have x, I'll replace it by this lower limit, which is minus 2. Let me do that. So you now have 2. That is this 2 times x to cube. Instead of x cubed, you now be times minus 2 raised to the power of 3 minus 5 times x. So it's now 5 times minus 2. So I'll now simplify each of these brackets there. So starting with this first one, 1 raised to 3 is 1 times this 2 gives you 2. And minus 5 times 1, you have minus 5. So you have 2 minus 5, which in the end will now be minus 3. I copied this minus. Look at it. This is the minus I copied here. I also simplified this very bracket. Minus 2 raised to 3 will give you minus 8. Minus 8 times this to 2 will give you minus 16. And this minus 5 times minus 2 will now give you positive 10. So you have minus 6 plus the 10. That will now end at minus 6. That is minus 16 plus 10. So I'll continue. So I'll now take this minus minus as plus. So you now have in the end minus 3 plus 6. And that gives you positive 3. So this is now the definite integral of this very function from minus 2 to 1 of this function 6x squared minus 5 with respect to x. Let me just take one more example. Example number 2, you are asked to find, or you are asked to evaluate the integral from 0 to pi of sine x plus 2 cos x with respect to x. Solution to this very problem. So what do we now do? We now write the given task. That is integral from 0 to pi of this function. So what we will now do? We will now find the integral of this very function. Remember, integral of trig functions. Integral of sine is minus cos, while integral of cos is sine. So there I'm going to find this integral. Integral of sine x will now be minus cos x. And the integral of 2 cos x will now be 2 sine x, then plus the constant of integration. Then I copied my lower and the higher limit to look at 0 and pi. So I'll continue. So I'll now start with the higher limit, which is pi in this case. So I'm going to replace the x by pi. Then later replace the x by this 0. Then I'll now find the two values and subtract. Let me go on and do that. So substituting x by this pi there, I'm going to have minus cos pi plus 2 sine pi. I have replaced the x in each case by pi. Pi, look at it here. Then minus, remember in the formula for definite integral, it says f of b minus f of a. So this is my f of b, that is the result after substituting the higher limit in the integral function. So substituting the lower limit now, I'm going to have minus cos 0 plus 2 sine 0. I have replaced the x here in the integral function by the lower limit, which is 0. So I continue. So I'll now find what will now be the value here after evaluating this cos pi and the 2 sine pi. Cos pi, remember, is nothing but minus 1, but I have the minus outside, so that gives me minus the 1 outside. Cos pi is minus 1 plus the 2 times sine pi. Sine pi is 0. Then I'll copy this very minus. Then I'll move to the second bracket. I'll now find what is cos 0 and what is sine 0. Cos 0 is nothing but 1 positive, and sine 0 is 0. So you now have this minus, I copied it. Then cos 0 is positive 1 plus 2 times sine 0, but sine 0 is 0. So I'm going to simplify the two brackets. There minus will now change it to plus. Then 2 times 0 is 0. So this first bracket will now have, instead everything will now be equals to positive 1. So I'm going to have 1. And so I move to the second part here. I have minus 1 over here. then plus the 2 times 0. 2 times 0 is 0. So I'm going to have minus 1 plus 0, which will now be minus 1. So I'm going to have minus 1 over there. But in this here, minus will now change it to plus. So in the end, you have 1 plus 1, which will end to be 2. So this will now be the definite integral from 0 to pi of this function sin x plus the 2 cos x with respect to x. The value there is now going to be 2. With the few examples given, my dear student, I hope you'll be able to find the definite integral of some function. So this is where I'm come to the end of this very lesson. Thank you for your attention. And let me just move to the last segment, which is fun, and explain interesting thing about the number 13. So it says 13 and 31. 13 and 31 are reverse of each other, and you can see it exactly. That is, 1 is the first digit in your 13, but in the 31 is the last digit, while 3 in 31 is the first digit, while in the 13 is the last digit. So they are mirror of each other. And what happened if we are to find the square of both the numbers, that is to find the square of 13 and find the square of 31, it will also happen that those two results will also be reverse of each other. This is really interesting. But let me just find the squares and see whether it is true. So 13 square, that is 13 times 13, the result will now be 169. So let me get 31 square. 31 square means 31 times another 31. And if you find this, if you do this multiplication correctly, you now have 961. And look at these two results, 169 and 961. You can see the last digit in your first result is now this first digit, while the first digit in the first result is now the last digit, and you can see 6 is in the middle. So these two results are reverse of each other, meaning they are mirror of each other, because writing this in reverse order, it gives you this, or writing this in reverse order, it will give you this. So this is really amazing, which I believe you never noticed this result. Thank you for your attention. We see more of this interesting thing in mathematics in our subsequent lesson.